All right. Okay. I'll just make coffee and maybe see if anyone else shows up as well, and then I'll start. So in like about 1, 2 minutes. Hi. Yeah, so I'm waiting like another 1, 2 minutes. I'll just make coffee in the meantime and I'll be back and then we'll start. Sorry. All right. Okay. Hi, everyone. So I'm gonna start. Feel free to just unmute yourself and interrupt me at any point. Like it's better when it's interactive because sometimes I just end up talking to an empty screen, and that is maybe not as good. I guess let me just ask quickly. For a show of hands, so who is here for project two and who is here for the lab? So who's here for project two specifically? Okay. And who's here for the lab? Okay. So in that case, I guess what makes sense is if you have general questions about project two, so general meaning not like I have this bug that they can't fix, but kind of clarification or like how to approach it, then I think maybe ask it now. And then I'll do the lab, and then I'm happy to answer individual questions afterwards, or I'll just like stop the broadcast and just like talk to people individually. All right. Yeah, so I'll just call on people who raised their hand. Well, so okay, so Sharyar had their hand up. Sharyar had his hand up, but
Yeah, so
yeah, so the test cases, yeah, I will release them after this session now. So I need to like prepare them and then I'll release them today, like this afternoon. Yeah.
okay, so I necessarily didn't have a deeper technical question. I was just confused about what parameters is it using to test against. That's it, nothing else.
Can you be more specific? So what do you mean, what parameters?
Yeah, so basically when I go to the auto test grader, it says test length for bound D border
I mean,
test.
that's the same as asking what's the test case. So let's say, yeah, so those will be released.
Those will be released before the deadline, right?
Yeah, yes.
Okay, then that's fine. Yeah.
All right. Is there kind of other questions? Okay. So yeah, so I have like a DM about detect rows. So let me and I think that might be, more an individual question, or it might be a general question, depending on the specifics. So let me kind of answer the general idea maybe about detect rows if you have detect row without the S, right? So essentially, what does detect row do, right? So it says we start with those coordinates, those specific coordinates, and then we're asking how many sequences are of this color, of this length in this direction. So let's say that you have that, right? So what that means is you can say, okay, like I want to do detect row on this row in this direction, starting from here. And then you could say, well, then I'll do this row, and then I'll do this row and this row and this row, and I'll just add up all the numbers that I get from all the different rows. And then I'll do the same thing for the vertical rows, and then I'll do the same thing for the diagonal ones. And the idea would be if you have detect row without the S, you can just go through all the rows, all the columns, all the diagonals, and add up the results from there. I'm not sure if that helps or not. If you want to like ask a follow up or like we can also talk individually later if that makes more sense. So like what I'm doing is I'm responding to a DM that I'm seeing like in the Zoom to be clear to everyone else. Does that yeah, am not getting a response in the DM to whether that made sense or not. So you can ask a follow-up later maybe, or like if you want, you can like DM me again. Okay. Are there other questions? You can also check the Discord. Okay. Um, anything else that people just want to ask or I don't know? Um, I mean, the problem would be that you are returning a different a different value than what's expected. So quite likely it's not because of so this is actually okay, like this I could tell you. So you can win with a closed sequence of five, and it kind of seems that you're not accounting for that based on the name of the test. Sure. All right. Are there other questions? Um, okay. In that case, like I'm doing like this is like the 1 p.m. lab session. So I'm just gonna do the lab. and that's going to be recorded as usual. Again, like interrupt me, even if you have questions about like project 2 that you're doing, I'm happy to kind of stop. Okay, so Charlotte, that just so I will release those test cases after this session. So I'll prepare them and release them. There is not like an easy answer here. It's just that it seems like your detect rows is not returning the right thing. And likely that's because detect row singular doesn't return the right thing. But yeah, like it's not the situation like before when I could just tell you what's going on because I don't know. Yeah. Okay. So we are doing lab what? Um
Lab 8.
Lab 8. Yes. Okay. So yeah, so problem 1 I actually did in kind of a session that happened, I don't know, Wednesday evening, I guess. So we're going to talk a little bit about files. So what does it mean to kind of how do files work in general? I'll just kind of talk a little bit about it. In general, files are organized on the computer in folders. So for example, I have, and this is going to be a little bit different on different operating systems and stuff. But in general, so here I have, the home folder. In my home folder, there is a desktop folder. In the desktop folder, I created the ESC180 folder. And then this has a whatever, like lab 3 from 2023, I guess. So usually kind of when you're displaying the folder, again, depends on the operating system. It might look like this. It might also look like this. Then usually change how it looks, right? So that's kind of the general thing. So what I'm doing here is I'm creating a text file. So, the way the text file would be is whatever I just type in the same way that you create programs. I can then say, save as, and I can save it, on my desktop as a.txt. So in general, so this .txt, this is called the extension in the same way that you have, .py or so the .py are like Python file, docx are like Word documents. So .txt would be what's called plain text documents. So we'll talk about kind of how file encodings work later in lecture, but there's different kinds of files. One thing to note is that I made it so that on my computer, and again, depends on the operating system, but I made it so that the file extension is displayed. So here it says like lab3.py, and I know that's a Python file, and it just says on other operating system, doesn't matter the operating systems, it's about kind of like what's the default thing. So sometimes the .py stuff, the .txt stuff is hidden. You can, again, like Google your specific operating system, it'll tell you how to display those if you want. Usually kind of the icon here indicates the type of file. So here it's, a Python file, and that's the picture for the Python file. So I saved a.txt on my desktop, so I can go and find a.txt. And this is this. It's a little bit annoying. So this is a.txt, and it displays here as a text file. So okay. So so that's like that, and the ECF ones actually work very similarly to my computer. So okay. So the instruction here is to create data2.txt. Doesn't matter. I created a.txt and I showed it to you in Python here. I can also open it here. this is it. Okay, so that's also a file that exists that just opens with the text editor. Again, like if you're working on your laptop, it might look a little bit differently, but basically this is what it is. So, okay. So I think that was problem 2. So problem 3 is write a program that opens data2.txt and prints all the lines in it that contain the word LOL in any mixture of lowercase and uppercase. So, okay. So here is what we need to do. So I have my a.txt. Let me say that I insert LOL here, and I can use .find. Okay. So first of all, I need to read the file like this. And then I need to actually get the text. So that would be like this. So what I usually do in Paizo is I save the file, the Python file that reads it to the same location where the data2.txt is. This would be lab8.py. And here my name was a.txt, so I'll do that. And then what I do is I say run file script. So the reason this is important is that when I say open a.txt, well, Python will not know where the file is, like which folder. So what I do is I place lab8.py in the same folder as a.txt, and then I run a script, and that makes it so that it opens the file a.txt that's in the same folder as the program lab8.py. So now that I've done it, I have text, looks like this. So now what I need to do is I need to print all the lines in the file that contain lol.txt. So for that, I need to look in the string thing. So here, there is a split. So split, and the idea would be that people would look around how to do it. So the way split works is if you say, something like this, and then you say split, that gives you on the top. That gives you a list of all the strings, right? Or for the strings that are separated rather by whatever you're splitting on. So in this case, we split on the period. And you get, this is the first element, this is the first element, this is the second element, the third element, and so on. So text initially is just this. If we split on the new line, what we get is a list like this. So I can say lines is text.split, like so. One annoying thing is that the last element is just going to be empty, and that's because the file here ended with a new line. So that's fine. So now what we need to do is we need to print all the lines that start with LOL, that contain rather LOL, right? So there's multiple ways of doing it. So one way is to use the find thing. So that's kind of what you wanted to look up. So the idea here would be that if you have LOL over here, this, say find LOL, it'll give you the location of the LOL. If you try to find something that doesn't exist, it'll just say -1. Okay. So the other thing is we want it to be case insensitive. So again, if you look up how to do that, then that would be the idea, is if you say something like dot lower, what you get is the all lowercase version of the string. So what you can do is you can say this dot lower dot find LOL, and this might be either -1 or the location of the first LOL. So what we do in general, so we say for line and lines. So this would be this guy, and then this guy, and then this guy. We're asking, is the lowercase line, we try to find LOL in it, is it going to be -1? And if not, that means that we print the line. It's going to be like this. So here, there are no lines that contain LOL. But if I go back and I maybe insert an LOL over here, save. So I saved using Control S. You can also do just like file save. Rerun this. That's going to print. Make sense? So, okay. So the next question is basically operate. Yeah, there's a question. Why did they do the -1? So that's because dot find, if it doesn't find the string that you're looking for, it returns -1. If it does find it, it returns the location. So in this case, it returned 4 because the first LOL, and in this case, the only LOL, starts at location 4. All right. So, okay. So what we're doing now is we're doing dictionary to string. So what we want to do is we want to basically convert this kind of thing to this kind of thing. So, okay. So what is the dictionary going to look like? So like something like this, right? And what we want to do is we want to build up this string. So I'll say result is initially just the empty string. And then just go through the items of the dictionary. So the usual thing. So what we had in our examples is we just printed those things out. So just pour my coffee, which is made red. But now what we're doing is we're adding those to the result string, right? So the way we do it, the format that's specified is you want key value new line, essentially. So that's what we're going to do. So how can we do it? So we need to have a string here. So one way to do it is to use the F string, right? So we can say F. And we're going to have a K, we're going to have a comma, and we're going to have a B. And we just add it. Then we want a new line at the end. So let's see how that works out. So I'll say S is dictionary to string of B. So B is like this, and S is like this. So what the handout actually specifies is you shouldn't have the last new line, right? Which is fine. So all you want to do is you want to say, well, I don't want the last new line, so I'll just return the result, but up to -1. Right? So I'll exclude the last character in the string. So now the string is going to look like this. By the way, the reason I'm displaying it in Paizo rather than just printing is that if you print S, it's going to look like this, which is like what we want, but it's maybe kind of harder to read than this in sense of having it be the expected output. All right. So now you want dictionary to string sorted. So what we want is we want to sort in ascending order by the key. Right? So it might be that things like this, but you want it sorted by the key. So, okay. Yeah, there is something in the Discord. Am I being stupid, or is this negative indexing not working? Okay. Well, like you got to be prepared for either answer. So so you're saying next y plus dx, next x plus dx. That seems fine. And then you're saying spot next, board next y, next x. So this seems fine. Oh, like you're saying next y. Like if you are using, so I think what's going on, if I'm reading what's happening correctly, is that your next y is -1, in which case it will return just the last element of the board. So like board of -1, like it's not going to crash, but it's going to return basically like the last row of the last column. Sorry, the last element of the last row, which is just like the lower right corner, which is probably not what you want. Right? No, because like it's like list it's at -1 is actually just like the last element. So it's like worse than crashing. It just like gives you the square that you probably didn't mean. All right. So okay, back to the lab. All right. Oh, we were sorted. Okay. So how can you do it? So here's one thing you could do. You can say, right? So if you remember, we had this in lecture where you can just say, d dot keys, and that's going to be whatever, like something that's list-like, and then you can just say, well, sorted of that, and that's just going to be the sorted keys. So now what we'll do is, like, instead of going through the dictionary in the default order, we're just going to say, for key K in sorted keys, you can do it in one line as well if you want it. We just go, at K, comma, D at K. Again, same thing. So we can try to mess up the order. So it's going to like maybe we're going to say, 5, 10. This. So S is going to look like this, whereas S sorted is going to look like this. Makes sense. Okay. So next thing. So okay. So what we want to do is we want to do the word count. So eventually what we want to do is kind of do Pride and Prejudice and find the most common words here. But we initially want to start with something smaller. So we want to see something like this, for example. So for example, this. And then we want to find the word count for, this small passage. And then we'll do it for the novel. So we'll start with this. And we'll read this in. So we'll say text is open. So this is the text. So we now want to just split it into words. So what the handout suggests is doing it like this. So that gives you all the words. And now we want to count them. So one thing you want to do, like in the previous question, is to just convert it to lowercase because you don't want to distinguish kind of lowercase letters and uppercase letters. So I'll rename this to just words. So that looks like this. So now what we want to do is we want to count up the words, right? So there's like all sorts of like weirdnesses about punctuations here. Punctuation here, we don't really want to deal with it now. Like that's good enough. That's the word. So, okay. So what I'll do is I'll say word counts, and initially that's going to be an empty dictionary. And what I'm going to do is I'm going to go through the words and I'm going to add up the counts for the words. So I'm going to say for word in words. And essentially what I want to do is I want to say word counts at word plus equal 1. If I see this word, I want to say, okay, I've seen it once, so I'll add like 1 more to the count for word. The problem is like maybe initially I haven't seen the word yet, so this is not a valid entry in the dictionary. So what I'll do is I'll say, well, like if the word is not in words, not in word counts, so I haven't seen it yet. Then the first time that they do it, I'll just set word counts at word to 1. If I've already seen it, then I'll do this. So then I'll add 1 to the counts. Let me make it a function. And I'll return word counts. And now I'll say, counts. Move it to the main block. Let's say W counts is make word counts words. Word counts is not defined. Because okay. So now W counts is going to look like this. So I appears 5 times, M appears 3 times, A appears 2 times, and so on. So this kind of makes sense. And this is kind of how you should work, right? So eventually we're going to analyze the novel, but initially what I want to do is just test it out on a small file. So, okay. So this is how it is. And I already created this test. So now what I want to do is I want to write a function that takes in a list of 100 integers, returns a list of the 10 largest integers. So this is just kind of like a warm-up for part C. So how do I get a list of the top integers? Well, what I can do is if I have, a bunch of integers, and sort them. That gives kind of the sorted version. When the top 10, what I can do is, so I can reverse them like this, if you remember. There's multiple ways of doing it. You can also do kind of a different sorted, but you can reverse things like this. And now if you don't actually want all of them, you just want the top 10, you can do something like this. So this is like automatically the top 10 because there's just not a lot of them. But if there is a lot of them, then you can do something like this, right? So you can say like from -10 up to -1 off sorted. So just do that. So with the tools, there's other ways, but with the tools that we have from this course, you would just do something like this, right? So this is just kind of, you can do it in 2 steps as well, but basically sorted of this. So this is the sorted version. And then you say, from the 10th to the end, up to the last is the top 10 because sorted by default does from lowest to highest. So, okay. So now what we want to do is the top 10 most frequent words. So here is one way to do, it, and that's kind of what's suggested in the handout, right? So we're saying the inverse, you can do inverse frequency like this. So you can say, okay, like if you have those frequencies, then you can sort by the frequency, right? So let me do that. That's like this, and this is the same kind of sorted thing, and it sorts by the key essentially. So like this is just the frequency here is just the name, but this is sorted by the key like this. And what you want eventually is the top most frequent words. So those would be like this and this and this. So what can we do? Can make the word counts, and then we can say, use it kind of combining the techniques. You can say, okay, get the counts. We need to make the inverse frequency. So instead of, if we do the items, what we'll get is we do W count items and we do sorted. What we get is the other thing, right? So it's sorted alphabetically. So what we want is we want to construct the opposite. So we want to construct items that are, 2A, 1 above, 1 ales, 1 O, and so on. So let's just do that. Yeah, Shariar.
Yeah, so I tried doing that. The problem is like, isn't keys like distinguished from each other? Like, how can
Yeah. So that's why I'm now about to construct the inverse items.
like there will be
But
different keys for each? Like, so there.
yeah, I need to like reverse them, right? So what I'll do is I'll just say, for like KV in W counts items, and now I'm just constructing the inverse items.
So for other key that is, for example, one, but there are three
Well,
words that.
I don't care. It's not a dictionary, right? So what I'll do is I'll literally say, like inverse counts.
Oh, this is a list, right? So we're
Yeah,
not
yeah,
using.
yeah. It's just a list,
Makes,
yeah.
yeah. I
So,
was
and
trying to
what
do
I'll append,
that kind of.
is WK. Yeah. So what you're asking, I think, is like, aren't there repetitions? And the answer is yes, there are, but I don't care. It's just a list. Right?
Yeah, makes sense. I was
Yeah.
trying to do the dictionaries and it didn't work.
Yeah. So now I'll do inverse count sorted, and that's going to be sorted inverse counts. And I can just do that. So let me show what it is. So it is now like this. And now I can just so what I want is like the top 10 words, I suppose. So I'll just do results. And now just count from the end. So I'll say for I range. I suppose what I'll do is I'll cut it off like this so that they don't have to worry what if it's like fewer than 10. I'll say -10 to the end like I did before. Why is it? Where is I? Oh, not -1, just like -1 in steps of -1. Yes. No, so it's sorry. So yeah, this. I think I'm trying to be too clever here. So I'll just do this. This is like this. I'll invert it like this. And not invert, but sort and reverse order so that now the most frequent one is at the top. And now I'll just extract the I, the man, the M, the my, and so on. So just like the top 10. The result is going to be literally empty. And I'll say for, so the way I can do, so like you can treat it as like a two-dimensional table, or you could just say for pair in this range, no, like for I in range, I guess. So here we're starting with 0 and we're going up until either 10 or the end of the list. So here I'm just saying like either I'm going up to 10 or I'm going up to the end of the list. And I'll append this guy at I at 1. So the word rather than this guy, right? So like so inverse consorted at 0 would be this, and then I want at 1, so I want the string. And we'll just return the results. So here, what I'll say is result is top 10 most frequent W counts. Invalid syntax. Minimum. It seems okay. Oh. Okay. Sorry, just 1 second. Okay, let me see what the problem is. That seems okay. That seems okay. Oh, I forgot the I. Okay. So now result is going to look like this. So those really are the top 10. So I'll now download the file from here. So this is Pride and Prejudice. So I'll just download it. I'll specify that I'm downloading it to the desktop. And I'll name it PNP. And now I'm ready to do the top 10 words in Pride and Prejudice. So just instead of the Dostoevsky, I'll do Pride and Prejudice. And here's the result. So those are the top 10 most common words there. Kind of makes sense. Yeah.
Yeah, like could you explain like in a very short brief from the point of inverse count sorted 10? Like I'm a bit confused about what's min doing here.
Oh, this is just like to account for the possible. So you're asking about this, right?
Yeah, from this,
Yeah,
but
yeah.
like
So this is just like to account for the possibility that there's fewer than 10 words. So like I don't want to go up until more than the length of this. Like usually it would be way more than 10. So certainly like for a novel, it's going to be way more. But you imagine that like for a very short text, there would be like fewer than 10 entries here. So I'm saying like either it's going up to 10 or it's going up to whatever is the length of this. If it's smaller, then I don't get an invalid index here because like I is like larger than 10, but there's no entry here that's like larger than 10.
And what's the like this double colon -1? Is it like the last or
This one.
yes?
So this is so if you remember, you can you can reverse a list like this. So if you have a list, you can reverse it like this.
Okay, and what makes sense? Okay.
All right. Cool. So okay. So now we are doing basically kind of the same thing, but with HTML. So here is kind of a file that's on the web. You can see the kind of text that corresponds to this kind of file. So this is an HTML file. This is what you usually see on the web. You can see the code for this if you do view page source. So this is what that looks like. Okay. So basically, there's kind of like a way to display text in boldface. So this would be like this. There is a way to make a hyperlink. This would be like this. And here is, a link as well. So what you can see is that for yahoo.com, and that's actually kind of depending on the search engine, but for yahoo.com, you can actually make a URL. So the thing that goes here that corresponds to a search for Python. Okay. And on yahoo.com, you can also look at, for example, the kind of the search results themselves, but also for the count of how many search results there are by just, you see that displayed, of course, in any search engine, you would see it displayed. But you can also just look at the source. And one thing you could do is you can say, well, like, where is this number in the source? And the answer is over here. So I just did like Control F and I found it. All right. So the big picture for this question is that you can actually just make make Yahoo search for whatever you want, and then you can query, and then you can figure out how many search results there are by looking at this file that yahoo.com actually generates. All right. But for now, we're just going to make an HTML file and make sure that we know how it displays and stuff. So, oops. So this is what we are doing over here. So here what we want to do is we want to save hello.html. Save it to the desktop. I'll name it hello.html. Can open it over here. So you'll notice that here, this is the hello.html that I saved to my computer. And I now get to change it. So I'll open it in Paizo. You can also do it in Notepad or whatever. So this on the desktop, it's called hello. That's annoying. So it's hello.html. So here it is. a little bit smaller. But that is definitely not the hello.html that they meant. Open it. What? Sorry, just one sec. Okay, this is definitely this. Saving it. Replacing. Did not save it to the desktop for some. No, that is on the desktop. Okay. Yeah, this is it. Yeah, so we are over here. Sorry, I was confused. Okay, so that is this is it didn't save the way I wanted to guess. Oh, I see what happened. So I was so we are over here. So this is the hello.html that they want. Sorry, I was like doing the view source and I was saving the view source. So I'll now save the right one and it'll hopefully update. No, I'm sorry. Okay, so this is what I want to save. Okay. It's going to be okay now. What? Sorry, I'm not exactly sure. So I'll save it as hello.one. Okay, close enough. This is the file, and we have the source code over here. So it says like, like hello anxi1f, whatever. There is a link. I think what the lab asks you to do, what they asked you to do in the lab is to kind of play around with this kind of stuff a little bit. So, for example, I can make anxi boldface like this, and then by so I saved it as hello one now. So this is the labs. So let me open the hello one file. So now anxi, for example, is in boldface. What else did they ask? So yeah, so Vinci was supposed to appear in bold. That's okay. So now I want to add a link to the search for engineering science. So that's kind of the more interesting thing. So if I go to yahoo.com, and I search for anxi, this is the search for rank size, so I'll add a link to that. And the link would look like this. Save it. And now we have the access search results like so. Make sense? So, okay. So what I want to do now is so what the lab asks, right, is to extract the number of results. So here the number is this one. So use source. So how would they find it? So one thing I can do is I can say, well, I can find where the search results are. So this says like search results span over here. And if you search for other things, what you'll find is like it always says this. So I can find the location of this. And then I say, well, the actual number is right on the left. All right. So how would they do that? I would say, so first of all, I need to construct the string, then I need to download this file, right? So to construct this string, like technically, like all of this is not really required. Really, what all I need to do is I need to just construct this kind of thing. So, okay. So I'll say URL is this guy plus query. So now the handout tells you how to get uh how to get the file, right? So I was skipping one thing, right? So here the suggestion is to do this. And here we're saying do this. So this is like opening a file, except you're downloading it from the internet. So we have our query. And this would be URL instead. So right now we're just printing the page. So let me just do that. So I'll say num search results inside. And it got me the page back. So now the idea is we're going to look for search results span. So that would be the location of this guy. So, okay, let's just do that. So for now, I'll just print it. So this is the location of this. And now I can say, okay, so I know the location. So what I can do is I can print what's to the left of this. How would I do that? So I would just say, okay, so I have page, and for now, what I'll print is just like the location minus 100 up to the location. So what does that look like? Well, it's like about, and then this much. So what do we need to do? Basically, in this guy, we need to find the location of this kind of thing, and then just look right after it. So how would we do it? I would say, okay, so S is this guy. And now I want to find the location of the about. So the reason I'm doing the angle bracket here is just so that I don't find like a random about that's not like this, right? So I'll do s dot find greater about. And now if I print s about location up to the end, what I have is this. So I want to isolate just this guy, right? So to isolate just this guy, what I can do is I can say about location plus the length of the about. Like this. So this gives me almost what I want, except there's like a space here. So I just add 1. And what I get is the string that represents the number of the search results. So I cannot directly convert it to an integer because there's an annoying comma here. So one thing that we kind of briefly saw in lecture is I can just remove the comma, right? So to remove the comma, what I need to do is I need to take the string and I need to replace all the commas with just nothing. So that's a number that I can convert to an integer. So that's what I'll do. Say int of this. And now I can print it as an integer. So that's what I want. So that means that I'll just make the function return this. And now I have the number of search results. So I can just do what the lab asks, which is have like query 1, query 2. And I can have the number of search results for query 1, the number of search results for query 2. And then I can say, so I can say if n1 is greater than n2, I can say winner user is q1, q2. And otherwise, it's the other way. And now I can say, don't remember what I asked to return, but I'll just print. this. And now hold this. And that is not happy. So just do it like this. So then, yeah, okay. So that's like this. Okay. So the reason this wasn't happy is like the space here, you need to look at how to query for multiple words. It's like you can't do it with a space. There is like %20 that you need to insert there. So that's just like technical details about Yahoo that are not really interesting. Okay. So I think that's about it for kind of the questions that I wanted to do from Lab 8. Yeah, I mean, like you can ask an officer. I mean, I wish you'd ask 30 minutes ago. Yeah, like you can ask anything you want, like in the same way that you can come to office hours as well and ask me. In fact, like you can ask now. Okay. Okay. Let me check if there is stuff on Discord. There's nothing on Discord. Okay, so I think what I'll do now is I'll stop the stream. If there's like specific questions, I'll stay for like a couple more minutes to answer questions, and then I'll yeah, I actually have another thing at 3 o'clock, and I promised to post the test cases. So a few questions, and then I'll come back for office hours, like whenever that was announced.